In this lecture, we will continue our discussion on nested and inner classes in Java.
In the last lecture, we noticed a problem when we tried to implement the ArrayList iterator class, in that it used the array and the size method from myArrayList. And since those were not declared in the ArrayList iterator class, we were going to get compile errors. So let's see if we can try to fix this problem. So here's one attempt at it. So this is our, at least a portion of the code where we have our myArrayList class. And it doesn't look really any different from the last time we implemented this. The only difference is this part right here in our iterator method, this right here. So what we're going to try to do is, since the size and the items and the size method do not exist in the ArrayList iterator class, let's just pass an object of myArrayList and see if that works. So this right here is saying we're going to pass the current object of myArrayList into the ArrayList iterator class. So here is the implementation of the ArrayList iterator class, and we notice that there are some differences from the last time we were trying to implement this. So notice that we do have a reference variable to myArrayList right here. So there's that. So we have a reference variable that's going to store an object. So our constructor for ArrayList iterator is passing an object of the myArrayList class. So we're going to store that list into the list. So now we can try to use the methods and variables from the list object. So in our hasNext method, we're going to do the list.size here, and then we're going to have the list.theItems current plus plus in our next method. Well, with all that, I have some bad news for you. This still doesn't work. I mean, the good news is that it solves the problem of not having the array and the size method in our ArrayList iterator class, because we're storing a reference to myArrayList, so we're just iterating over that. We even have the constructor that initializes the reference variable. So that means we can access the array field that's contained in myArrayList, but the problem here is the items array is private in myArrayList. And because ArrayList iterator is a different class, it's outside of the myArrayList class. That means that any private variable in myArrayList cannot be directly accessed. So we cannot directly access the items in our next method. So because it is a separate class, it's an outside class, we're not allowed to access it. Now you might think, well, we could make the items array public, couldn't we? Yeah, we could, but when is that ever a good idea? We always say make variables private, or at least protected. But this is a bad idea to make it public, so this doesn't work. Let's try this again. So here is the myArrayList class. It doesn't really look any different than what we've seen so far. We're still passing the current object of myArrayList through the ArrayList iterator. But one thing we're going to mention here, and you'll see it more clearly in the next slide, is notice that we have a curly brace missing right here. This is not a typo. This is intentional, because what we're going to see is we're not done with the myArrayList class yet. There's still more that we're going to add to it on the next slide. Now here is the implementation of the ArrayList iterator class. And what I want to point out here is this class is actually inside of the myArrayList class, because this curly brace down here, that corresponds to the end of the myArrayList class. So this entire class is inside of the other one. We're allowed to do this. And notice that the only differences between this implementation and what we saw previously is we have the words private and static in front of class right here. We'll see why this is necessary, but everything else is pretty much the same, I think. So we have still the reference to myArrayList inside of here. We still have our constructor that stores the list that we passed into the list. We still have the list.size here, and we still have the list.theItems and getting the current element and incrementing that in our next method. The good news is this solution actually works, and there is no bad news with it. This is a working solution. Yay, we did it. So what did we do here? We made the ArrayList iterator class a nested class. So what we mean by nested class is we just simply put the class inside of another class. So we're allowed to do that. We've talked before about subclasses where they implement or at least inherit stuff from the parent classes or superclasses. Here, we're just putting in a class definition inside of another class. That's perfectly fine here. So here, the ArrayList iterator is called a nested class. The myArrayList class in this case would be called the outer class. Now, in order for this to work, we have to include the reserved word static to say that this class is nested. That's why we had private static class ArrayList iterator before. If we did not include the word static, our ArrayList iterator class would become an inner class, which sometimes this is good, sometimes it's bad, depending on the situation. Believe it or not, nested classes are quite common in many of the different programming languages. And one of the things that we can take advantage of is the fact that the nested class can be made private. And this is really nice because then it's inaccessible except by the outer class. So anything beyond the outer class wouldn't be able to directly access anything inside the nested class. And this is a really good thing. But a bigger deal is that because the nested class is part of the outer class, there are no visibility issues with any of the instance variables or methods inside of either class. That means in this case, the items variable is visible for both a myArrayList and the ArrayList iterator. So we don't have to worry about whether or not ArrayList iterator can see the items array. It can because it is a nested class inside of the myArrayList class. Now there is a small problem with the nested class approach. So in our original design, we use the items array without having to refer to myArrayList. And the code looked nice and it made sense. You could look at the code and actually see, you should be able to understand what's going on in there. But the problem is that was illegal. We couldn't do that because the compiler couldn't deduce which myArrayList was being referred to because there was no connection between the items and myArrayList at that point. So it would be nice if we didn't have to keep track of this ourselves. Because by using the nested class approach, it's a little bit more complex. We have to be very specific about which object of the myArrayList class we're referring to. And it would be nice if we didn't have to do this, that it can be done automatically. And this is where we can take advantage of the inner class. The inner class does this for us.